do me a favor. Take a really deep breath. That invisible stuff you just breathed in, that's what we're diving into today. It's something we're in every single second of our lives, but we almost never think about it. It's Earth's atmosphere.
Now, really think about it. What are you breathing? Feels like nothing, doesn't it? It's totally invisible, it's everywhere, and let's be honest, without it, none of us would be here. So what is this stuff actually?
Well, that's the atmosphere. It's this amazing, invisible shell of air wrapped all around our planet. And what keeps it from just floating off into space? Gravity. You can almost picture it like a personal force field for the whole Earth.
And when you think about it, it's a really thin layer. Like if the Earth was an apple, the atmosphere would be just the skin. That's it. Almost all of it is packed into the first 100 kilometers above our heads. It's kind of a delicate blanket when you think about it that way.
Okay, get this. It's kind of hard to wrap your head around, but air has weight. It really does. Imagine a column of air stretching from the top of your head all the way to the edge of space. That whole column is pushing down on you. Right now, on every single square centimeter of your skin, it's pressing down with the force of about a 1 kilogram weight. Wild, right? That's air pressure. All right, so we've established it's this big mix of gases. But what gases are we talking about? What's the actual recipe for the air we're breathing? Let's break it down.
Now, here's something that surprises a lot of people. You'd think the air is mostly oxygen, right? Nope. Look at this. The huge majority, a massive 78%, is nitrogen. Oxygen comes in second, and then everything else is crammed into that little 1% slice.
So let's talk about that big chunk, the 78%. That's nitrogen. It's easily the most common gas up there. For the most part, it's pretty chill. It doesn't react with much. It's kind of like the filler gas. It's there to bulk things out and dilute the more energetic gases, like oxygen.
Okay, now for the 21%. This is the good stuff. This is oxygen. This is what it's all about for us. It's the gas that we and pretty much every other living thing have to stay alive. Absolutely essential.
And then that last little sliver, that tiny 1%, well, most of that is another sleepy gas called argon. But hiding in that 1% are also tiny but super important amounts of other gases, like carbon dioxide, which plants are desperate for, and water vapor, which is key for making clouds and rain.
So we've got the ingredients down. We know what the air is made of. But now for the big question, what does it do? And that 21% oxygen, well, it's at the center of this incredible cycle of life. I mean, this quote really nails it, that oxygen, just a fraction of our air, is the secret sauce for life. But how, exactly? What's it actually doing inside our bodies, down at the cellular level?
It all comes down to a process called respiration, and this is happening inside your cells right now. You eat food, that gives you sugar or glucose. You breathe air, that gives you oxygen. Your cells mash them together to get energy, and the leftovers are carbon dioxide and water. Simple as that. But wait, that's only half the story. Because plants, well, they do the complete opposite. It's called photosynthesis. They take the carbon dioxide we breathe out, suck up some water, and use sunlight as the power source to make their food. And guess what they release as a waste product? Yep, the oxygen we need. And when you put them side by side, it's just beautiful. Look at this. What we breathe out, plants breathe in. What plants breathe out, we breathe in. It is a perfect, balanced loop. It's literally the circle of life, spelled out in a chemical formula. So oxygen is the key to life, but it's also the key to something else, something that completely changed human history. I'm talking about fire.
The fancy science word for it is combustion, but we all just know it as burning. Think about it, the gas in your stove, the fuel in your car, the logs on a campfire. In every case, you've got a fuel that gets hot and reacts with oxygen from the air. And the result? A ton of energy. And to make fire happen, you always need 3 things. It's called the fire triangle. You need fuel, something to burn, you need heat to get the reaction going, and you need oxygen. You have to have all 3. Take away any one of those and poof, the fire's gone. And this is where our story takes a turn, because that same process, combustion, the thing that has literally powered our modern world, is now changing the very air we've been talking about. For the past couple hundred years, all of our activities, especially burning fossil fuels like coal and oil, have been releasing just incredible amounts of carbon dioxide, CO2, into the atmosphere, way, way faster than nature can handle it.
Now hold on. A little CO2 is a good thing. It's totally natural. It's what we call a greenhouse gas. And these gases act like a sort of invisible blanket around the Earth, trapping just enough of the sun's heat to keep our planet cozy and livable. So what's the problem? Well, by pumping all that extra CO2 into the air, we're making that blanket thicker. And what happens when you use a thicker blanket? You get warmer. It traps more heat. And that's causing the whole planet's temperature to go up. And there's a name for that effect: global warming. It's the rise in the Earth's average temperature, and it's happening mainly because we've been building up all these extra greenhouse gases in the atmosphere. So that brings us right back to the beginning. The air you're breathing right now isn't some fixed, unchanging thing. It's changed a lot over billions of years. But now, we're the ones changing it, and we're doing it faster than ever before. Which leaves you with a pretty big question. What is this invisible, life-giving shield of ours going to look like in the years to come?